All right, welcome back to the Institute. In this episode, we are basically going to solve about 4 to 5 questions. That is basically the Nigerians Wassce 2025 General Math and Further Mathematics questions, okay? So I'm going to help you guys with about 4 episodes, and in every episode, we'll have not less than 5 questions in each episode. So let's start. This question 1 here, we want to solve this integrand, right? Given this expression, we want to solve this integrand and find the value of what? M. So the question says that M is an integer, right? Now we want to find that particular M. So what do? We have to integrate this. So what we are going to do is to take the antiderivative, right? Antiderivative of this particular expression. So step one, you have to integrate this expression, right? So we are going to integrate this expression. And remember, if you have a function, right? Let's say you have something like this, and you want to integrate, first you add 1 to the exponent, then use the result to divide, right? So we add 1, making what? 4. So we have 4 here. We add 1 here, making what? 2. So we divide by 2. So we are going to apply the same knowledge to this particular function. Okay, so from here, step 1, we are going to integrate this. So we're going to have from -1 to m of 2x squared minus x minus 3 dx equals -9 on 2. Right? Now, this is the expression that we want to integrate. So we add 1 to the exponent here. So it's going to be 2x to the power 2 plus 1. Then we divide the whole expression by the exponent, right? So that is 2 plus 1 minus this, we add 1. Already there is a 1 there, so 1 plus 1. So we have x to the power 1 plus 1 divided by the same expression on the top. So we have 1 plus 1 minus 3. Remember, this 3 here in ideally is x to the power 0, right? You know that any number to the power 0 is what? 1. So that is why they just wrote what? 3. So now we want to add 1 to the what? 0. So it's going to what? 0 plus 1. So we're going to have x to the power 0 plus 1. Okay? So this is our integrand, right? From -1 to m. And that should be equal to -9 over 2. So this is what we have now. So let's try to simplify this. So we're going to have 2x cubed divided by 3. Remember, 2 plus 1, 3. Minus x to the power 2 divided by what? 2. 1 plus 1, okay? Minus 3x to the power 1. You know, any expression to the power 1 is the same expression. So that is it. Then from -1 to m, right? And that is equal to -9 over 2. All right. So from here, once you have been able to simplify the expression, what we can do now is to substitute the limits, right? So this is the upper limit, this is the lower limit. So first of all, you substitute the upper limit into the expression. Once you are done, you subtract this by substituting into this expression. So what I'm trying to say is that we're going to have 2 over 3 into m to the power 3 minus m to the power 2 divided by 2 minus 3m all minus, right? So we are done with substituting the upper limit into the expression. Now we come to the lower limit, right? So minus the lower limit, 2 over 3 into bracket negative 1 exponent 3 minus negative 1 exponent 2 over 2 minus 3 into bracket negative 1, right? Okay, so this is what we have, right? So we're going to simplify this, then we deduct it from this. So we're going to have, remember, it is equal to negative 9 over 2. Okay, so we have 2 over 3 m cubed minus m squared over 2 minus 3m minus negative 1 to the power 3 is negative 1. So we have 2 over 3 into negative 1 minus negative 1 squared is positive 1, right? So we have minus 1 over 2. Then negative 3 times negative 1 becomes positive 3. So we have plus 3, right? And that is equal to negative 9 on 2, right? So this is what we have now. So we can simplify this that after we subtract. So we have 2 over 3 m cubed minus m squared over 2 minus 3m minus, this will be minus 2 over 3, and then this will be minus half plus 3. This 2 on 3 plus half minus 3, you're going to have minus 11 on 6, right? So we have 2 on 3 m cubed minus m squared over 2 minus 3m minus 11 on 6 equals negative 9 on 2, right? So let's come up here. So we're going to have 2 on 3 m cubed minus m squared on 2 minus 3m minus 11 on 6 plus 9 on 2 equals 0, right? So we're going to add these two, right? So we're going to have 2 over 3 m cubed minus m squared on 2 minus 3m plus 8 on 3 equals 0. When you add these two, you have 8 on 3. Okay, so now we have to avoid these fractions, right? And the common denominator will be what? 6. Okay, 3 here, 2 here. The common denominator will be what? 6. So we say that multiplying through by 6, right? We're going to have 6 times 2 over 3 m cubed minus 6 times m squared over 2 minus 6 times 3m plus 6 times 8 over 3 equals 0. Okay, so you can see that 3 will go into 6 2 times. So we have 2 times 2, 4m cubed Then this will go here 3, right? So we have minus 3m squared minus 6 times 3, that is minus 18m. Then this will go here 2, right? 2 times 6, 2 times 8 is what? 16. So we have plus 16 equals 0. Right? So this is what we have. This is the expression that we have. Okay? So now, what we are going to do is that we are going to find a common factor, is that when we substitute, it will make this expression go to 0. And the only factor is 2. M minus 2 equals 0 is a factor. So m is equal to 2 is a factor. Right? So we are going to use this m minus 2 to find the other factors, right? Because this is a cubic expression. So we are going to use the long division, okay? We are going to use the long division to find the other factors. Okay, so the long division m minus 2, then we put the expression inside the minus 18m plus 16, right? So now, normal long division, right? So this will divide this, then we have 4m squared. This times this will give us 4m cubed. This times this will give us minus 8m squared. Then this here we don't have anything, so we put plus 0m plus 0, right? So we're going to subtract this minus this, we have 0. Then minus 3m squared minus 8m squared becomes 5m squared. So we have plus 5m squared minus 18m minus 0m becomes minus 18m. Then 16m minus what? 16 minus 0 becomes what? Plus 16. Right? We go again, right? So 5m squared divided by what? M will give us plus 5m, right? Then this times this will give us 5m squared. This times this will give us minus 10m. So then we subtract, right? But then we have to put our 0 here. So this minus this, we have what? 0 minus 18m minus 10m becomes 8m, right? We have minus 8m plus 16, right? So we have to go again, right? So this divided by this, then we have minus 8 here, okay? Right? Now, we have to use this to multiply this, right? So that times this will give us minus 8m. This times this will give us plus 16, right? So now we subtract. Minus 8m minus 8m becomes what? 0. 16 minus 16 becomes what? 0, right? So it means that our other factor is 4m squared plus 5m minus 8. So we're going to have m minus 2 times 4m squared plus 5m minus 8. Okay, so this expression has been broken down into a linear expression and a quadratic expression, right? So from here, we solve for m, right? So the first value for m is this. So that means that m minus 2 is equal to 0, m is equal to what? 2. And this is an integer, right? But we can conclude that this is the only integer for what? M. But this is our integer, right? This is an integer. Okay, so this is correct. Then we solve for this quadratic expression, right? This quadratic expression. That is 4m squared plus 5m minus 8 equals what? 0. We solve for this quadratically. And you realize that when you solve for that, you are not going to get an integer, right? It's going to be decimals. It's going to be a decimal. And remember, an integer is a positive or negative whole number, right? An integer is a positive or negative whole number. So then, this, we are not going to get a positive or negative whole number. Never, right? This, when you use the quadratic approach, the almighty formula, you're going to have m equals negative 3, negative 5 minus 3 square root of 7 divided by 8, divided by 8. Okay, or m equals negative 5 plus 3 square root of 17 divided by 8. And this is a decimal, this is also a decimal. Therefore, the value of m is 2. The value of m is 2. Okay, so the value of m from this particular problem is basically what? 2. So we can conclude that hence the value of m is equal to 2. Very simple, right? So if you have a problem of this nature, this is how you go about it systematically so that you'll be able to get it done very easy, very easy, very easy. So that is question number 1. Now let's move on to question number 2. Give me some very short break. I'll be back with question number 2. All right, welcome back from the short break. I believe that you have been able to go through the first question and you're good with it. Okay, now let's look at question number 2. We want to solve this logarithmic question, right? This logarithmic problem, which is 2 into bracket log x base 3 minus 1 equals log x base 3 and y equals square root of x plus 1 simultaneously. We want to solve this and this simultaneously, meaning we are solving this equation and this equation at the same time. So what we do, this we have to apply the log properties. Okay, so we write our first equation equals log x base 3 and y equals square root of x plus 1. That is equation 2. right? So what should we do? First of all, remember that we have log x base 3 and we have log s base 3. And remember, we can't solve this without doing anything to it, right? We have to allocate, or we have to let some variable represent this expression so that we can solve it, okay? So what we do is that we say that log x base 3 should represent a variable. I'm calling it t. You can call it a, you can call it c, whatever you want, okay? So let t equals log x base 3, right? So if t equals log x base 3, then wherever I'll see log x base 3, I'll substitute t. Okay, so we have 2 into bracket t minus 1 equals t, right? So let me expand this. When you expand this, you have 2t minus t, 2t minus what? 2 equals t. So meaning our t can be obtained from here. So that means that 2t minus t will be equal to what? 2. So we can say that our t is basically what? 2, right? So it means we have obtained our t to be what? 2. Now, remember that we said t should be equal to what? Log x base 3. So recall that t is equal to log x base 3. And now our t is 2, right? So we can say that 2 equals log x base 3, right? And remember, in the log properties, we know that if you have log x, let's say you have log 2 log s base 2, right, equals, let's say, 1. If you want to find this x from the basic properties of logarithm, you let this go and carry this, right, so that this will be isolated. So we say that 2 exponent 1 equals what? X. That is what you do, right? Now, we are going to apply the same knowledge on this one, right? So we say that this will be equal to 2 exponent 3, right? This will be what? 3 squared, and that will be what? X, right? So basically we can say that x will be what? 9. Okay, so that is it, right? So we applied this property, this basic property on this, and we have our x to what? 9. Once we have our x to be 9, what do? We can easily find our y, because our y from equation 2 is equal to square root of x plus what? 1. So from equation 2, we know that y is equal to square root of x plus 1, right? And now our x is what? 9. So we have y equals square root of 9 plus 1. And that is equal to 3 plus 1. And that is what? 4, right? That is so interesting, right? So we just applied some properties, and that is it, right? So if you have a problem of this nature, okay, remember logarithm has its properties, and so you have to follow the principles. So remember that in logarithm, if you have if you have so note, the answer for this is 9 and 4. That is, x is 9 and y is 4. So I want to give you some clues. If you have log a base log b base a plus log c base d, they are all having the same base, right? Then this is the same as log bc base a, right? The log property say that if you have the same log of the same base and they are adding, it means that indirectly they are multiplying. So that is it. Now, if you have log b base a minus log c base a, then indirectly this is the same as log b over c base a. Okay, so this is a property. And also, if you have log b exponent c base a, then it's the same as c log b base a, or the reverse also works, right? So these are some few properties that you have to know so that when you have a log property or a log problem, you don't have a challenge with it. So the value of this expression, solving this expression and this expression simultaneously, we had our x to be 9 and our y to be what? 4. So take note. That is it for question number 2. Now give me some short break. I'll be back with question number 3. So welcome back from the short break. Now, I believe that you have been able to go through the log question and you're through with it. This is question number 3. We are given this combinations, right? 8 combination x, 7 combination x, 7 over 6 times 6 combination x. These 4 items, or 1, 2, 3, form the first 3 conservative terms of an exponential sequence, right? That is the GP. Now we want to find the value of what? X, and then find the common ratio, and then finally we will find the first 10 terms of the sequence. Okay, so when you have a problem of this nature, first what you have to remember is that when we are talking about GP and you have terms of this nature, remember, if you have A, B, C, and you are talking about GP, then you know that when you take this and you take this, that means that B over A will be equal to what? This over this, right? So we have C over what? B. So this is the application of what? The GP. So we are going to apply the same knowledge here. Then we use some identities to solve this combination problem. So we are going to say that, remember, this is a binomial. We are going to use binomial coefficient, right? And so these are binomial coefficient, okay? So remember that this is 8 combination x, 7 combination x, and 7 over 6 times 6, 6 combination x. Now, we want to find the value of x in this combination terms. These are binomial coefficient, right? So remember that what I just did here, you take this over this, you take this over this, then you can solve for x. Remember, so this will be 7 combination x divided by 8 combination x, and that will be equal to 7 over 6 into 6 combination x divided by 7 combination what? X, right? So this is what we have. Now, remember that when you have 7 combination x is the same as 7, right? You can write it in this form, okay? You can write this in this form, right? So we are going to use this notation instead of this so that we can deal with the problem, right? So we're going to say that we have 7x divided by 8x, right? And that is equal to 7 over 6 into bracket 6x divided by 7x. Okay, right. So from here, what we have to do is that they are conservative terms of what? A GP. So the common ratio will satisfy this, right? Okay, so what we have to do next is that we have to use some identities, right? This is an identity that you have to know. So remember that this here, right? This here is the same as we are using the identities. So using the identities, you realize that 7 combination x all over 8 combination x is the same as 8 minus x over 8, right? 8 minus x over 8 minus x over 8, right? So we have 7 combination x divided by 8 combination x is the same as 8 minus x divided by 8, right? So this is an identity that you have to follow. This minus um, this minus this divided by this, right? So that is what we have here. And also, we take this 7 over 6, 7 over 6 times 7 minus x, 7 minus x divided by 7, right? 7 minus x divided by 7, right? So that is what we have here. So if this here is equal to this and this, which is this, is equal to that, then it means that we can equate this and this, right? So that we can have the value of x obtained. So that we can have the value of x obtained. So we are going to say that 8 minus x divided by 8 should be equal to 7 minus x divided by what? 7, right? So this basically, when you reciprocate it, the 7 will be cancelled, right? So we're going to have 8 minus x divided by 8 equals 7 minus x divided by what? 6, right? This, when you reciprocate it, it will cancel the 7. So we're going to have this. Now we can cross multiply, right? This goes here, this comes here. So we have 8 into 7 minus x equals 6 into 8 minus x, right? So we expand this, we expand that, then we can find the value of what? X. So from here, this and this, we have 48 minus 8x equals 6 times 8. That is 50. This is 48. This is 56. And this is 48 minus 6x, right? So this comes here, we have 56 minus 48 equals 8x minus 6x. Now this 56 minus 48 is basically 8, right? So we have 8 here equals 8 minus 6 is 2, right? So we have 2x. So when you look for x, we're going to have what? 8, 4, right? So the value of x will be 4. So we have 2x equals 8. So meaning that our x is what? 4. Right. So the value of x from this given GP is 4. Okay. Now, what we have to do next, we have to find what? The common ratio, right? The common ratio. So once we have the value of x, which is 4, we just have to substitute into this given expression, right? To have the common ratio. Okay, so we're going to have, so that's the value of x is 4. So when you substitute 4 here, you're going to have 8 minus 4 divided by 8. 8 minus 4 is 4, right? So we have 4 over 8 here, and this will give us half. So the common ratio is half. So the common ratio, R is half, right? So that is how we find the common ratio. Now the last part of the question says that we should find the sum of the first 10 terms, right? So how do we do this? Now remember that we have been given this consecutive terms, right? These consecutive terms, and we have been able to find the value of x. We have been able to find the common ratio, which is r. Now we want to find the first 10 terms of this expression. So remember that we have formula for it, right? A equals 1 minus r to the power nth term divided by 1 minus r. Remember, r should be greater than 1. So we're going to have should be less than 1 instead. Sorry. So we're going to have our sum of the first 10 terms, right? So s base 10, s10, s sub 10 equals 1 minus r to the power nth term divided by 1 minus r, right? And now remember that our nth term is 10. We have been given that we are looking for the 10th term, right? So our nth term is 10, right? And we know that our r is half. So we're going to have s sub 10 equals 1 minus half to the power 10 divided by 1 minus what? Half, right? So when you simplify this expression, you're going to have times this expression here is going to be 70 times 1 minus a1, right? Our first term is 70, okay? So let me put it there. So we have a1 times 1 minus a1 times 1 minus what? This. Okay, a1 times 1 minus this. Now we have half to the power 10 divided by 1 minus what? Half. And 1 minus half is what? Half. Right? So we have this to be 140, because this comes up and we have 140, right? Times 1 minus half to the power 10 here. So we have basically 140 times 1023 divided by 1024, and this is equal to 139.8632, right? So the 10th term, the first sum of the first 10 terms of the sequence is 139.8632. So the sum of the first 10 terms of the sequence is 139.8632. Right, so that is it for question number 3. We'll come back. Okay, so we end it here and continue in episode 2, where we continue to solve some more questions so that we can be very well prepared for our exams. Okay, so see you in episode 2. Bye-bye.